So this first one, in seeing that all four of our sides are the same, that should tell you that this is a rhombus. That is a rhombus. All four sides the same. And this one over here with the consecutive sides being congruent, that is the definition of a kite. And if you remember from yesterday, in the kite and a rhombus, the diagonals are perpendicular. Diagonals are perpendicular, and so that's what we use in those formulas. In both of these, the formula was 1/2 the product of the diagonals. 1/2 the diagonals multiplied together. So that was the formula for area of a rhombus, area of a kite. So that's what we're going to use. We have area equals 1/2 the product of the diagonals. Diagonal 1 times diagonal 2. Now these are both given to you. They're given to you in kind of a weird way, but they are given to you. It is the distance across here and across here, and both of those are given to you as 18. It's drawn in a weird way, but those are the diagonals, those sides that are marked as 18. So we put that in, we multiply that out. 1/2 of 18 is 9 times 18 is 162. And remember that if we have those units are going to be squared, since we're talking about our area. Over in the kite, now in the kite, I want to remind you of a property that we talked about in the kite when we had that great big chart that we filled out of all the things that are true about all these different quadrilaterals. One of the things that we marked that was true about a kite was that one of the diagonals got bisected. So things like a parallelogram, both of the diagonals got bisected. In a kite, just one of the diagonals gets bisected. So if this is 5, this is also 5. And now we know what the diagonals are, because we're going to be using the same formula for the kite that we did with the rhombus. So that's going to be 1/2. This entire diagonal all the way across is what? That entire distance all the way across. We have 10 here and 6 here for a total of 16. And then on the other diagonal, 5 here and 5 here, a total of 10. So we have 1/2 of 16 is 8 times 10 is 80 units squared. Yes, we're squaring units because we're still finding an area. Questions on that problem? All right. So what we're going to come up to is a couple of application problems here. And when we get all the way to the test, you're going to need to know how to pick out what type of thing they're asking about. So right now we have perimeter and we have area. And so you'll need to look at different situations and different contexts to ask, are we looking at area questions or are we looking at perimeter questions? So that's what you're going to see on this next problem. I'm going to be asking, is it an area question or a perimeter question? So let's move forward here. Let's do this one. You need to buy paint so that you can paint the side of a barn. A gallon of paint covers 350 square feet. How many gallons should you buy? So we're wanting to know how much paint we need to paint the side of a barn. Is that a perimeter question or an area question? That's an area question. We want to know how much space we need to paint something. So you'll notice that we have two different shapes happening here, because this is not just one specific shape. This is two shapes kind of layered on top of each other. We have a rectangle down here, and then we have a triangle up here on top of the rectangle. So what we're going to do is we're going to take those separate areas, find them, and then we're going to combine them together. And that will give us our formula. So first of all, let's start with the rectangle because it's easy. Rectangle, length times width, or base times height, 26 times 18. Now, the triangle is a little bit more complicated because we have this side is 26, but we don't have the base and the height, which are over here. Luckily, the base and the height are going to be the same because it's an isosceles triangle. Those two sides are the same. Well, if it's an isosceles triangle, then what that's going to do is that's going to make it so that these angles are the same. This is a 45, 45, 90 triangle. So that's how we're going to solve it. We have the hypotenuse is 26. Now, if you don't remember your 45, 45, 90, then you can certainly use trig. You know the hypotenuse. Maybe you want to find your opposite. You can use sine and do it that way. But I'm going to be using the 45, 45, 90 pattern because I think it's quicker. Because to get the hypotenuse, we take those legs and multiply it by square root of 2. So if this is already multiplied by square root of 2, to get these sides, we take the 26 and divide it by square root of 2. And then if we wanted to be fancy and simplify it, we can multiply by root 2 on top and bottom, which would give me on top 26 root 2. And on bottom, we have square root of 2 times square root of 2. And we know that square root of 2 times square root of 2 is 2. So we have 26 on top and 2 on the bottom. Those can reduce because they're both outside of the square root. And we get 13 square root of 2. And remember, those are the same. It's an isosceles triangle. Those are the same. So we know that that's both the base and the height. So if it's both the base and the height, then we can plug it into our area of a triangle formula of 1/2 base times height. They're both 13 square root of 2. So let's do some multiplying here. Everything inside the square root, we have square root of 2 times square root of 2. And I just said the square root of 2 times square root of 2 is 2. And then we have the 13 times 13. So the 1/2 and the 2 are going to cancel out to leave us just with 169. So those are my two separate areas. So now to get the total area that we need, that's going to be the rectangle and the triangle combined together. So we're just going to take the 468 and add it to the 169 and add those together. And our units are going to be in feet squared. We squared? Yes, we are, because we're answering an area question. So yes, it should be in feet squared. Oh, wait a second, we haven't actually answered the question yet. Because we say a gallon covers 350 square feet. How many gallons should you buy? That's what the question is asking. So to answer that question, we decided that we need 637 square feet. That's how much we need to cover. So let's divide to figure out how many gallons we need to cover it. That's 1.82. So in order to have enough, we should probably buy 2 gallons. Because if we only buy 1 gallon, we're going to run out. So 2 gallons is our final answer here. Questions on that problem? All right. Again, we're going to look at a problem, a situation, and we're going to pick out whether this is a perimeter question or an area question. So, design of a racetrack consists of a rectangle and 2 half circles. And we're being asked, what is the distance of 1 lap around the track? What is the distance of 1 lap around the track? Is that a perimeter question or an area question? That's a perimeter question because we're asking for the distance around my track. So there are a couple different pieces to the track here. I'm going to call S my, just for shorthand, so I don't have to keep writing it out. I'm going to call S for my straightaway and T for my turn. There we go. So S for my straightaway, T for my turn is how I'm going to abbreviate the rest of these. So to get the total perimeter, we are going to take, let's start our race here. We're going to run the straightaway here. So we ran the straightaway, and then what do we have? We have a turn. Okay, and then after that, it's another straightaway. And then after that, we have our final turn coming down the home stretch. Can we do it? And yes! I win. I'm so good at this. Track is easy. So we've made the final turn. So to get our perimeter, we're going to add all those pieces together. All right. So first of all, our straightaway. Well, we don't need any formula for the straightaway because that's just straight line segment. So that's going to be 329. Done. But the turns are a little more complicated. By the way, you'll notice I haven't used the 300. All right, we're not cutting inside along the grass because we're not cheaters. I won my own race that I made up in my own mind, fair and square. No cheater here. So we are going to use the 300, but it's not a distance. It's going to be part of our formula for half circle. So we want distance around, and we want to talk about circle. But when we talk about circles, we don't talk about perimeter. We're not talking about perimeter. What's our word for distance around a circle? Circumference instead of perimeter. So our total distance here Well, our circumference is 2 pi r. That's our formula for circumference in a circle. Circumference is 2 pi r, but it's only a half circle. Those turns are only a half circle, so we're going to take that circumference and cut it in half. So that means the half cancels with the 2, and that's just going to be pi times the radius. So what is my radius? It's not the 300, because it's the distance from the center out to a point on my half circle. That's my radius. So if the whole thing across is 300, then the radius halfway across is 150. So don't forget, if you have that diameter all the way across, you need to cut it in half to get our radius, which is 150. So we have pi times 150, that's 150 pi. All right. So time to put that into our formula and actually get our perimeter. We have S here for my straightaway, that's 329. We have our 150 pi for my first turn. We have another straightaway, that's 329. And then our final turn is the 150 pi. Okay. Now, pi is going to work the same as our variables and square roots do in terms of thinking about them as like terms. In other words, I can't add and combine something with a pi to something without a pi. All right, so if I wanted an exact answer and to leave it in terms of pi, I would combine my 329s, which would give me 658. And then separately, I would combine my 150 pi and 150 pi to give me 300 pi. So that's the exact answer. If you wanted it to leave it in terms of pi and get an exact answer, that would be how you would leave it. Now, if it asked you to round the answer and get a decimal, then we would actually plug in and put 658 plus 300 pi. And there is, by the way, a pi key in the calculator. And pretty much all your calculators, there is a pi key. It's along the right side on the TIs, over nearby like the division symbol and all that. But there is a pi key, so I can just put 658 plus 300 pi into the calculator. And if I do that, I get 1,600 meters squared. No, not meters squared this time because it's a perimeter. So that is just that distance around the shape. So 1,600 meters is that entire race.